Okay? So, again, in the flow experiment, we've modeled the range of the flow versus time, right? And I'm not sure we've got that data. If I have to, I'll make some up, but I kind of think that we have it somewhere. I think we wrote it on the board, so I'll be able to find it. We can make a graph of the horizontal range, which is how far the water hit out on the meter stick when it hit the sidewalk, right? We'll have data that might look something like this. I think we'll have about 5 points. So what we can do is, first of all, physics tells us, and also if you do this experiment with great accuracy, you find that it's so, that this horizontal range is very, very close to a straight line in actuality, in reality. Okay? Now, because of uncertainties, because those of you who are watching the flow hit, you weren't sure. You're pretty sure within a couple of centimeters of where the thing was hitting, right? And if you're good at seeing the pattern, you might have been closer than that, but you still got some uncertainty because I mean, the water spread out about that much when it hits. Okay? So you kind of look for the middle of that, but it's fluctuating because there's a little bit of a breeze. So you get a lot of noise in the data, essentially, meaning that the data doesn't form a perfect straight line. Okay? But you can fit best straight line you can draw, which is a line, you can think of it this way, this isn't quite right, but you can think of it as a line that comes as close as possible on the average to the data points. It doesn't go through any data points just like the other one didn't. Okay? If it goes through a data point, that's just an accident. You're trying to get the trend. So you fit a straight line. Okay? And how are you going to get the equation of that line? Now, I will say that I've seen some people take the y equals mx plus b form of a straight line and take 2 points on the line, plug it in, and get two simultaneous equations that solve for m and b. Okay? Well, we're not to that point yet, but yes, that's just as valid as what we did up here, right? But we're going to use this, okay? Using fundamental triangles, okay? And what you're going to have to do is you're going to have to pick 2 points on that line, draw the fundamental triangle for those points, find its slope, and then take any one of those points and put it in a fundamental triangle with x, y, get the slope of that triangle and set them equal, right? Or, you know, once you've done the fundamental triangle for 2 points, then you have the slope, haven't you? And then you just need the fundamental triangle for one more point, and you set that equal, and you get the equation of the line, okay? And then we'll try to figure out where that line hits 0. Well, that's very, very easy. You set a linear function equal to 0 and solve it. Nothing to it, right? Okay? When this hits 0, what should be going on in the bottle? Again?
Should be getting empty.
Should be what now?
Getting more. Are you talking about like the bottle or the liquid? What are you talking about?
Yeah, in the bottle, when this thing hits 0, what should happen? What should be happening in the bottle?
The flow should go down. The quantity should go down at the bottom.
Well, quantity is going down, right?
Yeah.
But if this hits 0, exactly what's happening? Well, why would this hit 0? What's that mean about water coming out of the tube? there's none coming out. So what's going on in the bottle if there's nothing coming out of the tube?
I'm in the wrong place.
It just stopped, right? Well, what's that correspond to in your quadratic model? Doesn't that correspond to the vertex? Because at the vertex, that's when the flow stops, isn't it? Now, we'll be a little more specific about exactly why that's true. But one of the things I love about the flow model is this interplay between the two graphs. This thing ought to hit 0 at the same instant that your flow rate hits the vertex. Okay, it won't because nothing's ideal, but it'll be pretty close. Okay? That makes sense? Now, the physics of it is the difference between these, if done very accurately, tells you something about the viscosity of the water. And you really want to learn about that, right? No, you don't. It's beyond the scope of this course, okay? And you really need quite a bit of physics to understand this. So we're not doing that, but you know, that's one of the things that happens. It tells you something about the real world, tells you something about the behavior of water. And if you're on a planet with some unknown substance that didn't kill you, and there's a river of it, you could do this experiment and figure out if you could swim in that river or whether you would just sink. Okay? Well, not really, but something like that. Okay? You could at least tell how much resistance you get if you try to swim in the water. Okay? Wouldn't tell you anything about buoyancy. Okay, well, that's kind of where we're going. Okay? It won't take us long because we've got all the pieces in place. Okay, so do good on this major quiz. Again, you know, if you still want to complete a practice quiz, you can slip it under my door, put it in the box anytime. I'll try to get some feedback on it for next time. If you've already done it, great.